In electrochemistry, we study interconversion of electricity and chemical reaction. Electricity is the flow of electron, and in chemical reaction there is exchange of electrons. So electrons can be the connecting link between electricity and chemical reaction. But not all the chemical reaction. Specifically, redox reaction is used for the interconversion of chemical reaction into electricity. But why is a redox reaction only used for the electrochemistry? In redox reaction, oxidation and reduction take place simultaneously. Oxidation is the loss of electron and reduction is the gain of electron. So there is flow of electron between oxidation and reduction reaction that can be used to generate electricity. For the interconversion of electricity and redox reaction, we require some device. For the conversion of redox reaction into electricity, electrochemical cell is required. And for the conversion of electricity into redox reaction, electrolytic cell is required. Electrochemical cell uses spontaneous redox reaction to produce electricity. Electrolytic cell uses electricity to facilitate non-spontaneous redox reaction. In this video, we are going to discuss the use of electricity to facilitate non-spontaneous redox reaction. So let's try to understand what is non-spontaneous redox reaction. Electrolytic cell used to facilitate non-spontaneous redox reaction. For example, there is water. When you heat this water, you will get water vapors. When you further heat this water vapor, you won't get H2 gas and O2 gas. In water, oxidation number of hydrogen is +1 and oxidation number of oxygen is -2. And as you know, oxidation number of any element in its standard state remains 0. So oxidation number of hydrogen in H2 gas is 0 and oxidation number of oxygen in O2 gas is also 0. So the conversion of water into H2 gas and O2 gas is a non-spontaneous redox reaction as it doesn't take place under normal condition. To produce H2 gas and O2 gas from water, we require electricity and the process is known as electrolysis. For this conversion, electrolytic cell is used. Similarly, when you heat NaCl, you will get molten NaCl, but when you further heat it, you won't get solid sodium and chlorine gas. In NaCl, oxidation number of Na is +1 and oxidation number of Cl is -1. And as you know, oxidation number of an element in its standard state remains 0. So in sodium, oxidation number of sodium is 0. In Cl2, oxidation number of Cl is also 0. So when you convert NaCl into Na and Cl2, sodium get reduced while chlorine get oxidized. As this conversion doesn't take place under normal condition, it is non-spontaneous redox reaction. Again, we will require electricity for this conversion and the process is called as electrolysis, which can be done by using electrolytic cell. So let's see how do we construct electrolytic cell. For the construction of electrolytic cell, electrolyte is required. Electrolyte is the solution of ionic salt, which can conduct electricity. And these are the electrodes. Electrodes can be made up of metals or non-metals. They provide the surface for oxidation and reduction reaction. In electrolytic cell, these electrodes are connected with the battery. One of the electrodes is connected with the positive terminal of the battery and another electrode is connected with the negative terminal of the battery. Now let's try to understand the working of electrolytic cell. Electrons are supplied from the negative terminal of the battery to the connecting electrode. So this electrode become electron rich. As it become electron rich, it can provide electrons for the reduction reaction. Reduction take place on this electrode. That's why this electrode is called as reduction electrode. Reduction electrode is also known as cathode. From the electrolyte, cations gain electron from this electrode and convert into neutral species. And the electrode which is connected to the positive terminal of the battery become electron deficient. As it become electron deficient, it facilitates oxidation reaction. So the oxidation take place on this electrode. That's why this electrode is called as oxidation electrode or the other name of oxidation electrode is anode. As anode is electron deficient, anion loses electron to this electrode and get converted into neutral species. Now let's study the electrolysis of molten NaCl. Here electrolyte is the molten NaCl. As we have discussed earlier, anode is electron deficient and it is the oxidation electrode. So oxidation takes place on anode. Cl negative will lose electron to oxidation electrode and convert into Cl. So we can write the equation 2Cl negative gives Cl2 gas plus 2 electrons. Now come to the cathode. Cathode is the reduction electrode and reduction takes place on cathode. So Na plus ion will gain electron from the reduction electrode and convert into Na. So we can write Na plus electron gives Na solid. Now let's combine oxidation and reduction reaction into redox reaction. When you combine both the reaction, you will get redox reaction. So here we will write 2Cl negative gives Cl2 gas plus 2 electron. This is the oxidation reaction. Now write the reduction reaction. So here Na plus electron gives Na solid. Now add the oxidation and reduction reaction. But before addition, you have to balance the electrons. As there are 2 electrons produced in the oxidation reaction, 2 electrons must get consumed in the reduction reaction. So here we need to multiply reduction reaction by 2. Now add both the reactions. On adding, we will get 2Na plus 2Cl negative gives Cl2 plus Na. So this is the complete redox reaction. So as a result of electrolysis of NaCl, Na will get deposited at cathode and Cl2 gas will liberate at anode. So let's re-examine the reduction reaction take place at cathode. When 1 mole of sodium ion gains 1 mole of electron, 1 mole of sodium metal is produced. Is it possible for us to calculate the amount of current required to deposit 1 mole of sodium? Or is it possible for us to calculate the amount of sodium get deposited on passing 1 ampere of current for 1 minute? That means, can we calculate or convert the current from mole of electrons? So let's see how we can interconvert current and moles of electrons. Current is the charge per unit time. An electron is a charged particle. Charge over 1 electron is equal to 1.6 into 10 raised to minus 19 coulombs. So we can calculate the charge over 1 mole of electron as well. So here you have to multiply charge over 1 electron by Avogadro number, that is 6.022 into 10 raised to 23. When you solve it, you will get charge over 1 mole of electron is equal to 96487 coulomb. It is also equal to 1 Faraday. So Faraday is a bigger unit of charge and 1 Faraday is equal to 96487 coulomb, or almost you can take it as 96500 coulomb for solving numerical problems. To convert moles of electron into current, first you have to calculate Faraday from the charge of electron. Then you will be able to calculate current from the Faraday. So here you have seen Faraday can be the connecting link between redox reaction and electricity. Question is that, what is the mass of copper metal produced at cathode during the passage of 5 ampere of current through copper sulfate solution for 100 minutes? Molar mass of copper is 63.5 gram per mole is given. To solve such kind of problem, first of all you have to write the reaction take place at cathode. Cathode is the reduction electrode, so reduction take place at cathode. Now identify the cation that undergo reduction reaction. So in copper sulfate, copper 2 plus ion is the cation which undergo reduction. Now write the reduction reaction take place at cathode. Copper 2 plus ion plus 2 electrons gives copper. So from the reaction, you know 2 mole of electrons are required to produce 1 mole of copper. Charge over 1 mole of electron is equal to 1 Faraday. That means to produce 1 mole of copper, 2 Faraday charge is required. So first of all you have to calculate the charge passes through the copper sulfate solution. 5 ampere current is passes for 100 minutes and we know Q is equal to I into T, where I is the amount of current in ampere and T is the time in second. So here you will get 5 ampere multiplied by 100 multiplied by 60 seconds. When you solve it, you will get 30,000 coulombs. Now convert this coulomb into Faraday. 1 Faraday is equal to 96500 coulomb. So when you divide this amount of charge by 96500 coulomb, you will get 0.31 Faraday. And we know 2 Faraday charge is required to produce 1 mole of copper. So 0.31 Faraday will be required to produce 0.31 Faraday multiplied by 1 mole divided by 2 Faraday. It will be equal to 0.1 mole of copper. Now we know mass of the substance will be equal to number of moles multiplied by molar mass. Molar mass of copper is given 63.5 grams per mole. So when you multiply 0.15 mole by 63.5 grams per mole, mole will get cancelled out with the mole and you will get 9.87 grams of copper. This is the answer of our question. That means on passing 5 ampere of current for 100 minutes, 9.87 gram of copper will get deposited at cathode. Now let's try to solve another question based on it. In electrolysis of AgNO3 solution, 0.42 grams of Ag is produced at cathode after a certain period of time. Calculate the quantity of electricity is required. Molar mass of Ag is given 108 grams per mole. Now again write the reaction at cathode. Identify the cation. Here NO3 carries -1 charge, so Ag will carry +1 charge. And this Ag positive will undergo reduction at cathode. Now write the reaction take place at cathode. So it will be equal to Ag plus ion plus electron gives Ag. So from the reaction we know 1 mole of electron is required to produce 1 mole of Ag. Or 1 Faraday of electricity is required to produce 1 mole of Ag. In the question it is given that 0.42 grams of Ag is produced. So let's convert this amount in moles. We have the formula number of moles is equal to given mass in grams divided by molar mass in grams per mole. Now place the value in the formula. Given mass is 0.42 grams. Molar mass of Ag is given 108 gram per mole. When you solve it, you will get 0.0038 moles of Ag. From the equation we know, to produce 1 mole of Ag, 1 Faraday current is required. So how much Faraday of current is required to produce 0.0038 moles of Ag? So to produce 0.0038 moles of Ag will be equal to 1 Faraday multiplied by 0.0038 is equal to 0.0038 Faraday. Now convert this Faraday into coulomb. You know 1 Faraday is equal to 96487 coulomb. To convert this value into Faraday, you have to multiply it by 96487. So here you will get 366.6 coulomb of charge is required to produce 0.48 grams of silver. So this is the answer of our question. So here you have observed when we pass 1 Faraday of current, 1 mole of Ag is produced, and when we pass 0.0038 Faraday of current, 0.0038 mole of Ag is produced. Means the amount of substance deposited is directly proportional to the charge. When we increase the charge, amount of substance deposited will also get increased. And if we decrease the amount of charge, amount of substance will get deposited will also get decreased. So this is the first law of Faraday. Mass of substance deposited W will be directly proportional to the amount of charge passed through the electrolyte. When you remove this proportionality sign, you will get a constant that is Z. And you know Q is also equal to I into T. So when you replace the value of Q in this formula, you will get W is equal to ZIT. where I is the current in ampere and T is the time in second. And Z is the electrochemical equivalent. It is the amount of substance get oxidized or reduced on passing 1 ampere of current for 1 second. Or you can say 1 coulomb charge. So how do we calculate electrochemical equivalent? Electrochemical equivalent is equal to equivalent weight divided by 96500 coulomb. Here I have rounded up the value of 1 Faraday from 96487 to 96500 coulomb for the ease of calculation. Equivalent weight is equal to molar mass multiplied by mole ratio. But what is the mole ratio? So let's see what is mole ratio. Mole ratio is the number of moles of substance produced on passing charge of 1 mole of electron. To calculate mole ratio, you have to divide number of moles produced in half reaction by number of moles of electrons involved in half reaction. Actually, number of moles gives you an idea about how many moles of a substance can be produced on passing 1 mole of electrons. Let's try to solve a few examples based on mole ratio. For example, you have to calculate the mole ratio for the given equation. In this half reaction, 1 mole of sodium is produced on passing 1 mole of electron. So when you calculate mole ratio, 1 mole of sodium is produced in half reaction and 1 mole of electron is involved in half reaction. So when you solve it, you will get 1. That means 1 mole of electron will produce 1 mole of sodium. Now let's calculate mole ratio for the given equation. Here 1 mole of Cl2 is produced in the half reaction and 2 mole of electrons are required in half reaction. So when you place the value in this formula, you will get 1 mole of Cl2 is produced in half reaction divided by 2 moles of electron involved in half reaction. On solving it, you will get mole ratio is equal to half. That means 1 mole of electron will produce half mole of Cl2. Now come to the trick to solve numerical problems based on first law of Faraday. To calculate moles of a substance produced at either of the electrode, you have to multiply number of Faraday by its mole ratio. And Faraday can be calculated by dividing coulombs by 96500. So here you will get another formula. To calculate the number of moles of a substance produced is equal to charge in coulombs divided by 96500 coulomb per mole multiplied by mole ratio. And we know Q is equal to I into T. So when you substitute the value of Q in this formula, you will get another formula. Moles of a substance produced is equal to I into T divided by 96500 coulomb per mole multiplied by mole ratio. To calculate mass from the moles, you have to use the formula mass is equal to number of moles multiplied by molar mass. So you will get another formula. Mass of substance produced is equal to I into T divided by 96500 coulomb per mole multiplied by mole ratio multiplied by molar mass. So from this formula, you can directly calculate mass of a substance produced. Now let's try to solve same question that we have discussed by using these tricks. What is the mass of copper metal produced at cathode during the passage of 5 ampere current through copper sulfate solution for 100 minutes? Molar mass of copper is 63.5 grams per mole. First of all, you have to write the reaction take place at cathode. So you will get copper 2 plus ion plus 2 electrons gives copper. Now calculate the mole ratio for this equation. 1 mole of copper is produced in the half reaction and 2 mole of electrons are required in the half reaction. So here you will get mole ratio is equal to 1 by 2. Now write the formula to calculate the molar mass. We have the formula mass of substance produced is equal to I into T divided by 96500 coulomb per mole multiplied by mole ratio multiplied by molar mass. I is given 5 ampere, time is given 100 minutes. So here you have to multiply it by 60 to get time in seconds. Mole ratio we already have calculated and molar mass is given 63.5 grams per mole. On placing the value, you will get 5 ampere multiplied by 60,000 seconds divided by 96500 coulomb per mole multiplied by 1 by 2, that is the mole ratio, multiplied by 63.5 grams per mole. On calculating it, you will get 9.87 grams. Now let's see what happens when we connect cells in a series connection. In a series connection, we know same amount of current will pass through each cell. So how much substance will get deposited on cathode of each cell? So let's see. First of all, write the reaction take place at cathode for each cell. In AgCl, Ag plus ion will get reduced at cathode. So here you will get the equation Ag plus electron gives Ag. In case of MgCl2, Mg2 plus ion will get reduced at cathode. So here you will get the equation Mg2 plus 2 electrons gives Mg. In AlCl3, Al3 plus ion will get reduced at cathode. So here you will get the equation Al3 plus 3 electrons gives Al. Now calculate the mole ratio. Mole ratio is equal to number of moles produced in half reaction divided by number of moles of electron involved in half reaction. So in case of Ag, 1 mole is produced and 1 mole of electron is required. So mole ratio will be equal to 1. In case of Mg2 plus ion, 1 mole of Mg is produced by using 2 moles of electron. So mole ratio will be 1 by 2. In case of Al3 plus, 1 mole of aluminium is produced in half reaction and it required 3 moles of electron. So the mole ratio will be 1 by 3. For example, if we pass 1 Faraday of electricity through this circuit, can we calculate the amount of substance? We have the formula mole of substance produced is equal to number of Faraday multiplied by mole ratio. So here we have used 1 Faraday of electricity. So when we multiply 1 Faraday by mole ratio of Ag is 1. So 1 mole of Ag will be produced in the first cell. Similarly, you can calculate the amount of magnesium produced in the second cell by multiplying 1 Faraday by its mole ratio. So here you will get 1 by 2 mole of magnesium will produced at second cell. And in the third cell, 1 Faraday of electricity is passed through the cell and mole ratio is 1 by 3. So here you will get, 1 by 3 moles of aluminium will be produced in the third cell. Now let's take a short break from here and try to understand how to calculate number of equivalents. You already know equivalent weight is equal to molar mass multiplied by mole ratio. To calculate number of equivalent, you have to divide given mass by equivalent weight. Equivalent weight is equal to molar mass into mole ratio. So when you place the value of equivalent weight in this equation, you will get number of equivalents is equal to given mass divided by molar mass into mole ratio. And we know number of moles is equal to given mass divided by molar mass. So we can substitute given mass divided by molar mass by number of moles. So you will get another equation, number of equivalents is equal to number of moles divided by mole ratio. Now let's calculate number of equivalents here. We have the formula number of equivalents is equal to number of moles produced divided by mole ratio. Here 1 mole of silver is produced and the mole ratio is 1. So the number of equivalent will be equal to 1 by 1 will be equal to 1. Now calculate the number of equivalents of magnesium produced in the second cell. Here half mole of magnesium is produced and the mole ratio is half. So when you calculate the number of moles, you will get half divided by half. When you solve it, you will get 1 by 2 multiplied by 2 by 1. So here 2 and 2 will get cancelled out and you will get the answer 1 equivalent of magnesium. Now calculate the number of equivalents of aluminium. Here 1 by 3 mole of aluminium is produced and mole ratio is 1 by 3. So here you will get number of equivalents will be equal to 1 by 3 divided by 1 by 3. When you solve it, you will get 1 by 3 multiplied by 3 by 1. 3 and 3 will get cancelled out and you will get 1. When you observe all the cells, you will see on passing same amount of charge, equal number of equivalents are deposited in each cell connected in series connection. So according to second law of Faraday of electrolysis, the amount of different substances liberated or deposited by the same quantity of electricity passing through the electrolytic solution are proportional to their chemical equivalent weights. Or in other words, you can say equal number of equivalents of different substances liberated or deposited by same quantity of electricity passing through electrolytic solution. Now let's solve one problem based on it. In a certain electrolysis experiment, 4.36 grams of zinc are deposited in one cell containing ZnSO4 solution. Calculate the mass of aluminium deposited in another cell containing AlCl3 solution connected in series with ZnSO4 cell. Molar mass of Zn and Al are 65.4 grams per mole and 27 grams per mole respectively. So this question is based on second law of Faraday. According to second law of Faraday, on passing same amount of charge, equal number of equivalents are deposited on each cell connected in series connection. So if we can calculate the number of equivalents of zinc deposited, we will be able to calculate the amount of aluminium deposited. So let's calculate the number of equivalents of zinc produced. In the question, 4.36 grams of zinc are deposited, that is given mass, and molar mass of zinc is 65.4 grams per mole. First of all, write the reaction take place at cathode in the cell containing ZnSO4 solution. In ZnSO4 solution, zinc 2 plus ion will undergo reduction. So you will get the equation Zn 2 plus ion plus 2 electrons gives Zn. Mole ratio for the given equation will be equal to number of moles of zinc produced in half reaction, that is 1 mole, and there are 2 mole of electrons are required in half reaction. So here you will get mole ratio 1/2. And we have the formula number of equivalents is equal to given mass divided by molar mass into mole ratio. Given mass is 4.36 grams. Molar mass of zinc is given 65.4 grams per mole. And mole ratio we just have calculated 1/2. So when you place the value in it, when you simplify this, you will get 4.36 multiplied by 2 divided by 65.4. When you solve it, you will get 0.13 equivalents of zinc. So we just have calculated 0.13 equivalents of zinc are produced. Now write the reaction take place in the another cell that contain AlCl3 solution. So at cathode, Al3 plus ion gains 3 electron and converted into aluminium. Mole ratio for this given equation will be 1/3 as 1 mole of aluminium is produced by using 3 moles of electron. Now we have the formula number of equivalents is equal to given mass divided by molar mass into mole ratio. According to second law of Faraday, number of equivalents will be same as the zinc. Given mass that we have to calculate, molar mass is given 27 grams per mole and mole ratio we just have calculated 1/3. Now place the value in this formula. So here you will get 0.13 equivalents is equal to X. We can take given mass is equal to X divided by 27 multiplied by 1/3. So 3 ones are 3, 3 nines are 27. So here you will get X divided by 9. When you shift 9 to the other side of the equation, you will get X is equal to 0.13 multiplied by 9. When you solve it, you will get 1.17 grams of aluminium will get deposited in another cell. And this is the answer of our question. Now let's see how we can solve this question in a short trick. According to second law of Faraday, on passing same amount of charge, equal number of equivalents are deposited on each cell connected in series connection. Means if there are two cells, number of equivalents of A will be equal to number of equivalents of B. Now write the formula to calculate number of equivalents. So here you will get mass of A divided by equivalent weight of A will be equal to mass of B divided by equivalent weight of B. When we rearrange this equation, you will get mass of A divided by mass of B will be equal to equivalent weight of A divided by equivalent weight of B. And we have the formula to calculate equivalent weight is equal to molar mass multiplied by mole ratio. So when you substitute the value of equivalent weight in this formula, you will get given mass of A divided by given mass of B will be equal to molar mass of A multiplied by mole ratio of A divided by molar mass of B multiplied by mole ratio of B. By using this formula, let's try to solve the previous question. First of all, write the reaction take place at cathode for both the cells. So here you will get Zn2 plus 2 electrons gives zinc. Mole ratio for this reaction will be 1/2 as we have calculated earlier. Now write the reaction take place at another cell. So you will get Al3 plus 3 electrons gives aluminium. Mole ratio for this equation will be 1/3. Now we have the formula given mass of aluminium divided by given mass of zinc will be equal to molar mass of aluminium multiplied by mole ratio of aluminium divided by molar mass of zinc multiplied by mole ratio of zinc. Now place the value in this formula. Given mass of zinc is 4.36 grams. Molar mass of aluminium is 27 grams per mole. Mole ratio of aluminium we have calculated 1/3. Molar mass of zinc is 65.4 grams per mole and mole ratio for zinc we have calculated 1/2. Now place the values in this formula. So here you will get given mass of aluminium divided by 4.36 is equal to 27 into 1/3 divided by 65.4 into 1/2. So here it will get cancelled out and here you will get 9. And when you transfer 4.36 to the other side of the equation, it will go in the multiplication and you will get 9 into 4.36 divided by 32.7. When you solve this equation, you will get 1.17 grams of aluminium will get deposited in the another cell.